Hey, this is Mr. Janes, and in this video we're going to talk about the area of different kinds of polygons. In previous videos, we've talked about how to find the area of circles and parts of circles called sectors. You also probably learned how to find the area of squares and rectangles in middle school. So today we're going to review a few of those things from middle school and also add on how to find the area of different kinds of polygons. Before we begin, let's do a quick review of special right triangles. Now, you won't need special right triangles for what we're doing in this video. However, when we get to more advanced problems with areas of polygons, you will need special right triangles. So let's just get them down on the paper. Remember, we have two special right triangles. We have our 45, 45, 90 triangle, and the ratio of those sides are x, x, and x square root 2. Remember that? And we also have a 30, 60, 90 triangle, okay? And the ratio of those sides are x, 2x, and x square root 3. Hopefully you remember those from just a couple months ago. Now, when we're finding area, it's very important that we know what units we should use. Normally when we're finding length, we could use units like centimeters, or meters, or feet, or yards, or miles, things like that. But when we're finding the area of something, we're finding how many square centimeters, or square inches, or square feet fit into a certain place. So we usually write that centimeters squared, or meters squared. You may also see it as square centimeters, or square meters. But often we just use this as a shortcut. And again, this is just for length, and this is for area that we're going to be talking about today. So let's start with the most basic area formulas we have, a rectangle and a square. If a rectangle has sides that are a base and a side that is a height, the area of that rectangle is base times height. We've done that before. Or if we've got a square, we know that all the sides in a square are congruent. So if I've got a base of a square, then this will also be the same exact length. So the area of a square is the base times itself, or the base squared. So you'll see here the space that says y. We're going to save that to explain why the area formulas are the way they are in each of these problems. We'll do that tomorrow in class. For now, let's hop straight in and try some problems. Please pause the video here and try and find the area of the shaded region for the square and the rectangle up next. When you're ready, unpause the video. Alright, here we go. So, first up we've got the square. We know that all the sides of a square have the same length. So the area of a square is 5 squared, well, or 5 times 5, that is why they call it squared, which is 25. The rectangle is a little more difficult. We know the area of a rectangle is base times height. Now we have our base, that's 16, but we don't know what our height is. We're not sure. Well, luckily they give us that this diagonal here is 20, and this is a right angle, a right triangle. What do we know we can do with right triangles? Pythagorean theorem. So let's set it up to find the height. We'll have height squared plus 16 squared equals 20 squared. Since we don't have too much room here, let's work it out on the next page. So here's my equation, h squared plus 16 squared equals 20 squared. So let's see, 16 squared is 256, 20 squared is 400. We'll bring the h squared right down. We subtract 256 from both sides, okay, to get that h squared by itself. And we're left with h squared equals 144. We take a square root to cancel out that squared on both sides. We have h equals 12. Now that we know that the height equals 12, we can go ahead and find the area of this rectangle. Again, the area is base times height. The base is 16. The height is 12. And when you multiply those together, you get 192. Now, they don't tell us what kind of units we're using, centimeters, meters, whatever. So I'm just going to write units squared to cover my bases. Units squared. That's the units that should have. Next, the area of a triangle. We know the area of a triangle is 1/2 base times height. Or you can think of it as base times height divided by 2. Either one works. but it's important to know what exactly is a base and what exactly is a height. Well, on a right triangle, it's pretty easy. The base is the bottom side, and the height is this side. Now, the height is always perpendicular, or at a right angle, to the base. So in an isosceles triangle like this one, we've got to drop the height straight down from the top. There's the height, and the base is this bottom. In an obtuse triangle, it's a little more difficult. The base is right here, but the height is actually this distance right here, from the top of the triangle down to where the base would be if we extended it over. That's the height. At this point, if you feel comfortable, go ahead and try the next 3 problems about triangles. Pause the video and unpause it when you're ready. Alright, let's find the area of some triangles. First up, this one. This is pretty clear cut. The base here is 7 and the height is 4. It's important to note that the base covers the one side of the triangle and the height is perpendicular to that base. So the area of a triangle is 1/2 times the base, which is 7, times the height, which is 4, and you should get 14 units squared. Centimeters, meters, whatever it is, squared. Second one is slightly more confusing. What's the base and what's the height? Well, remember, the base is the side of the triangle. So 7 here is not the base, it's 5. And the height is perpendicular to where the base is. So the height here is 4. So the area of this triangle is 1/2 5 times 4, which gives us an area of 10. This last one's a little tricky too, because here's the height, but what's the base? We don't know. But luckily, just like the problem before, we have a right triangle, and they gave us this hypotenuse, 10. So we can set up Pythagorean theorem. We have 6 squared plus the base squared equals 10 squared. I'll work that out on the next page. Alright, 6 squared plus b squared equals 10 squared. 6 squared is 36 plus b squared equals 100. That's 10 squared. Subtract 36 from both sides. Okay, and we're left with b squared equals 64. Take the square root of both sides to cancel out that square root, and b equals 8. Now that we know that b equals 8, we can go ahead and find the area. Remember, area is 1/2 the base, which is 8, times the height, which is 6. 1/2 times 8 times 6 is 24. Again, 24 units squared. Next, we'll talk about equilateral triangles. Now, equilateral triangles are a little bit special. There's a special formula that works only for equilateral triangles and no other ones. If you know what the side length is, say this is S for the side length, okay, it should be the same all the way around, then the area of an equilateral triangle is the square root of 3 over 4 times the side length squared. Now, it's a little confusing how we get to that, and so we'll leave the y for in class, but let's just use that formula. If I've got an equilateral triangle right here with sides 5, 5, and 5, then my side length is 5, and the area is the square root of 3 over 4 times 5 squared. 5 squared is 25, so the area is 25 square root of 3 over 4. Pause the video here and just try setting up the next one. Alright, let's take a look. The side length of this triangle is 11, and we know it's equilateral because all the angles are the same, so it's 11 on all sides. Again, we have this special formula only for equilateral triangles that says that it's the square root of 3 over 4 times 11 squared. 11 squared is 121, so the area of this equilateral triangle is 121 square root of 3 over 4. Again, we'll get to the y during next class, but for now, just stick with that formula. On to parallelograms and trapezoids. Now, these are two formulas that are kind of related. The area of a parallelogram is base times height, just like it is for a rectangle. However, it's a little bit different. The base, of course, is this part right here, but the height is not this. That is not the height. The height is, if you drop a line perpendicular to the base. Just like for triangles, the height is perpendicular to the base. Same thing with parallelograms. So there's our height right there. For trapezoids, slightly different. The height is the same thing. It's perpendicular to the base. But we've got two bases. So we're going to call this one base 1 and this one base 2. The area of a trapezoid is base 1 plus base 2 divided by 2 and multiplied by the height. If you'd like to, pause the video here and try finding the area of the next two problems. Alright, here we go. First one we have is a parallelogram. Looks like we've got our base right here is 9. Our height is 4. Remember, our height is going to be this length right here. This length in purple is not the height. The height has to be perpendicular to the base, just like that 4 is. So, the area of our parallelogram will be 4 times 9, which ends up being 36. As for the next shape, that's a trapezoid. It doesn't really look like a trapezoid, like we like to think of one, like over here, but it is. Remember, a trapezoid is any quadrilateral that has two parallel sides. One of the bases is 8, the other base is 4, and the height is 6. Remember, the height is perpendicular to the bases. This right angle tells us that that is a height. So, the area of a trapezoid is base 1, which is 8, plus base 2, which is 4, divided by 2, times the height, which is 6. 8 plus 4 is 12, divided by 2 is 6, times the height, which is 6. And 6 times 6 is 36. So interestingly, both of these quadrilaterals have the same area of 36. Now, this last formula is about regular polygons, and I'm actually not going to have you use this formula in this video at all. It's a little more complicated to use, but I'll just explain it to you and have you write it down. For regular polygons, the area is 1/2 times the apothem, which is A, times the side length, which is S, times the number of sides you have. Let me explain what that means. The apothem of a polygon is the distance from the center of the polygon to the edge, or to a side that's perpendicular. That's called the apothem. That's A. The side length right here is S, and the number of sides is just the number of sides in the polygon. In this case, there are 5 sides. In this case, there are 6, and in this last one, there are 4. Okay. Now, we're not going to get into why that works, and I'll just try one right here for you. Okay. In this first one, we have a apothem of 15. They don't give you the side length, and that's the difficult part. You've got to figure it out. For now, we'll just pretend the side length is 10. Okay? And then the number of sides here, it has 5 sides. So the area of this pentagon, 5-sided figure, is 1/2 times the apothem, which is 15, times the side length, which is 10, times the number of sides, which is 5. If you do that all out, the area is 375. Now we're going to leave these kinds of things for kind of tier 2, tier 3 problem. So for now, don't worry about it, just write these down. Make sure you have this formula here. If we get to tier 2 or 3, we'll work on this in class. The most important takeaways from this video are that you know how to find the area of a rectangle and square, even if you have to use Pythagorean theorem. You know how to find the area of a triangle, even if you know how to use Pythagorean theorem. And lastly, you know how to find the area of a parallelogram and a trapezoid. And you know, you might have to use Pythagorean theorem even if you didn't here. So again, the biggest things are squares, rectangles, triangles, parallelograms, and trapezoids. If you know how to find the area of those, the regular polygons and the equilateral triangles are just extra that we'll talk about more next class. Make sure you're ready for your video check, and I'll see you then.